We're now in chapter 4, which is dealing with factors and prime factorization. A factor is when whole numbers other than 0 are multiplied together. Each number is a factor of the product. In our first example, you're working on your school's yearbook. Each page will have 24 student photos. Your photos will be arranged in a rectangular display with the same number of photos in each row. How many ways can you arrange the photos so that there are no more than 10 photos in any row or column? So notice that we have the term factor. So we will be using the factors of 24 to determine how many ways you can arrange the photos. So on our next screen, when you're asked to list the factors, you know that they will each have a mate, but I want them to be listed in numerical order. So for example, the factors of 24 would be 1 and 24. So start at the beginning and then put the mate at the end. 2 and 12. 3 and 8. And then 4 and 6. Now we've listed the factors of 24. That's how many student photos you have. But the question is wanting to know how many ways can you arrange the photos so that there are no more than 10 photos in any row. So we're going to put them in pairs. For example, you can have 3 rows of 8 photos, or you can have 8 rows of 3 photos. Because they're asking them to be no more than 10 photos in each row. So our next set could be 6 rows of 4 photos, and then 4 rows of 6 photos. Now the original question was asking how many ways can you arrange the photos so that there are no more than 10 photos in any row or column. So that would be 1, 2, 3, 4. 4 ways would be your final answer. But you will also need to show how you got that answer. Now, we're going to check numbers 1, 2, 3, and 4. I'm going to ask you to list the factors for each of those numbers. Order them from least to greatest. I'm going to pause the video. We'll come back and check your answer. Now you notice that we put them in order from least to greatest. Use our divisibility rules to determine what each of the factors are. Now, when you list the factors, unless you're really careful, sometimes you can miss one of the factors. So we're going to learn a step that will help you get every factor in that you need to. Our terms are called prime number and composite number. A prime number is a whole number that is greater than 1 and has exactly 2 whole number factors, 1 and itself. Composite number is a whole number that is greater than 1 and has more than 2 whole number factors. The number 1 is neither prime nor composite. To determine whether a number is composite, you need to find the only factor other than the number itself and 1. Also, 2 is the only even prime number. So now we're going to talk about another way to write the factorization without missing any of the factors. It's called prime factorization. writing a number as a product of prime numbers using a diagram called a factor tree. So in this example 2, we're asked to write the prime factorization of 630. So you take 630, and I'm going to pick a prime number, 3. 3 times 210 is 630. I'm going to circle the 3 because it's a prime number. Now I'm going to factor out 210. Circle the 3. Now the first step is to do what's called the factor tree. The second step, in order to write the prime factorization, is you list the prime numbers in order from least to greatest. This is one example of a factor tree. Your factor tree might look different from mine, the actual tree. But the prime factorization at the bottom, 630 is equal to 2 times 3 squared times 5 times 7, will all be the same. You might have chosen different factors, but in the end, the prime factorization will look the same. Now in this checkpoint, you'll notice in your exercises, they're going to ask you to tell whether the number is prime or composite. If it is composite, then you are asked to write the prime factorization. I'm going to pause the screen, and I'm going to ask you to work these out, writing number 1 if it's prime or composite, and then if it is composite, the prime factorization of it. So you'll notice that even if your trees are different, your prime factorization should be the same. 5's on number 5. The number 32's prime factorization is 2 to the 5th power. Number 6, for the number 56, the prime factorization is 56 is equal to 2 cubed times 7. Notice I put them in order. I put them in order from least to greatest. And then number 7, we went through the divisibility rules for 7 and 8, and notice that they were both prime numbers. Our next terms, it would be called monomial, and we're going to be factoring monomials. A monomial is a number, a variable, or the product of a number and one or more variables raised to whole number powers. So look at the chart that I have for you. Our monomials, the examples are 7x, 25mn squared, 24y cubed z squared. We have examples of not monomials, 7 plus x, 25m minus n squared, 24 plus y cubed plus z squared. Notice the difference in those two charts. Monomials and not monomials. You need to be aware of how to determine if it's a monomial or not and noticing the difference. Now, you're going to be asked to factor a monomial. Write the monomial as a product of prime numbers and variables with exponents of 1. Now I'm going to show you another way to use prime factorization other than a tree. It's called the upside down division, or L method. You take your number, and we'll use the 28. We are going to divide using prime numbers. So the prime factorization of 28 is 2 times 2 times 7. And now we've got to factor the variables. So I have 1x, and I have 3y's, and as instructed, you are to factor that out with variables with exponents of 1. So you have the choice of either using a factor tree for the prime factorization or you can do the upside down division or L method. Either one will help you determine what the prime factorization is for the numbers. And in the variables, when you're using them, you have to factor them out, just as I'll give you an example now. Now we're going to checkpoint. We're going to factor the monomial. Now in these examples, you can do them without doing a tree or upside down division. Because I know the prime factorization of 6 is 2 times 3, then A times B. You're factoring the monomial. You know it's a monomial, so you would just factor it out. Prime factorization of 15 would be 3 times 5. N cubed would be n times n times n. Our last example, 3 times x now on 16. You can do either prime factorization method that you like to determine what the prime factorization is of 36. I'm going to pause the video and come back for that. Okay, you'll notice I chose to do the factor tree. In my prime factorization factoring of the monomial, I listed them in order from least to greatest for the prime factorization of that monomial.